Hello all. In the chapter light we have already discussed about the phenomenon of reflection and refraction, and also we had seen the laws of reflection as well as laws of refraction. Now we are going to know about one of the important concepts regarding light, that is the refractive index. We know that refraction of light occurs when light travels from one medium to other. That is, for refraction to occur, there should be a change in the medium. This is because the speed of light changes with the medium. And this is the reason for the phenomenon of refraction. Now we know that there is a bending process happening when refraction occurs, and the extent of bending or the deviation is given by refractive index. Refractive index is the value that gives the extent of change in direction of light when it travels from one medium to the other. Now, as we told that the speed of light changes with the medium, and that is the reason behind refraction. So bending of light depends on the speed of light in different medium. So we can say that, in other words, refractive index describes how much light slows down when it enters a particular medium. That is, how much the speed of light changes when it enters from one medium to the other. So refractive index is a quantity that gives us the extent of change in direction of light when it travels from one medium to the other, or in other words we can say that refractive index describes how much light slows down when it travels from one medium to the other. Now in the second law of refraction we had seen that sin I by sin r is a constant which is also known as Snell's law, and this constant is actually the refractive index. Let us consider the refraction of light when it travels from one medium to other, and we are naming the first medium as medium 1 and the second medium as medium 2. And here in this process we know that the incident ray will make an angle with the normal, and it is called the angle of incidence, and the refracted ray making an angle with the normal is known as the angle of refraction. And according to Snell's law, the ratio of sin I by sin r is always a constant for a given pair of medium, and it is known as the refractive index. So refractive index of second medium with respect to first medium is denoted as n21, and it is given by the equation sin I by sin r. We should clearly understand the notation that when light travels from medium 1 to medium 2, the ratio sin I by sin r gives the refractive index of second medium with respect to first medium. So refractive index is defined for a pair of medium, and the refractive index of second medium with respect to the first medium is given by sin I by sin r. Now we can also describe the refractive index in terms of speed of light. We already have understood that the phenomenon of refraction is caused because light travels with a different speed in different medium, and therefore a refractive index can also be defined in terms of speed of light in medium. Let the speed of light in medium 1 be v1 and speed of light in medium 2 be v2. The same case, that is, light is entering from medium 1 to medium 2, and we consider the speed of light in medium 1 to be v1 and medium 2 to be v2. Then here the refractive index of second medium with respect to first medium in terms of speed of light can be written as n21 is equal to v1 by v2. So this is how we define refractive index in terms of velocity. So we have seen that to define refractive index we need a pair of medium, and we say the refractive index of one medium with respect to the other, and we can define it as n21 is equal to sin I by sin r, and also in terms of velocity n21 is equal to v1 by v2. So we know that the notation n21 is the refractive index of second medium with respect to first medium, and in terms of velocity we wrote it as speed of light in first medium divided by speed of light in second medium gives the refractive index of second medium with respect to first medium. This should be kept in mind very clearly, that the refractive index of second medium with respect to first is given by speed of light in first medium divided by speed of light in second medium. If we denote n21 as refractive index of second medium with respect to first medium, then we can write n12 as refractive index of first medium with respect to second medium, and it is given by the expression v2 by v1. The refractive index of first medium with respect to second is given by v2 by v1, which means speed of light in second medium divided by speed of light in first medium. So this is how we define the refractive index for a given pair of medium. Under the discussion of refractive index till now, we had been discussing the refractive index of one medium with respect to the other. Now we are going to see the absolute refractive index of a medium. How can we define the absolute refractive index for one medium? Absolute refractive index for a medium can be defined only if our first medium is always air. If the first medium is air and from air light enters to some other medium, then there the refractive index is defined as absolute refractive index of the medium. So we can define absolute refractive index as the refractive index of a medium with respect to air or vacuum is called absolute refractive index of the medium. Nm, and it is denoted by Nm given by speed of light in air divided by speed of light in medium. This is actually refractive index of medium with respect to air. Therefore, equation will be having speed of light in air divided by speed of light in medium. But this is defined as absolute refractive index of the medium. This is the standard representation of the absolute refractive index of a medium. And the speed of light in air is c. And the speed of light in air is denoted as c, which is equal to 3 into 10 to the power 8 meter per second. This is the speed with which light travels in air or vacuum. Actually, this is the speed in vacuum. Coming to air, the speed will be slightly less. In air, this speed is marginally less, but we consider the speed of light in air as c itself. And let us denote the speed of light in the medium as v. Therefore, the absolute refractive index Nm can be written as c by v, where c is the speed of light in air and v is the speed of light in medium. So, if we want to find the absolute refractive index of a particular medium, we have to consider the first medium as air, and when we enter the light from air to the medium, with the help of the speed of light in these two, we can find the absolute refractive index of the medium, which is given by Nm is equal to c by v. And some values, that is the absolute refractive index of water, that is Nw, denoted as Nw, is equal to 1.33, and the absolute refractive index of glass is obtained as 1.52. So these are some standard values of refractive index. For every such medium, we can have the absolute refractive index. So we have got the idea of refractive index and also absolute refractive index. Now, related to this, we can also define medium as optically rarer medium and optically denser medium. This is defined based on the speed of light in the medium. In rarer medium, the light travels faster, and in denser medium, the light travels slow. Now in terms of refractive index, we know that refractive index of a medium is inversely proportional to the velocity in that medium. We have seen that the velocity of the medium comes in the denominator for the expression of refractive index of a medium. That is refractive index is inversely proportional to velocity. So from this we can say that the denser medium in which the light travels slow, that means velocity is small, the refractive index will be higher. So denser medium has higher refractive index and rarer medium has low refractive index. So this is the definition of optically rarer medium and optically denser medium. And here we have to note one important point is that this denser medium or rarer medium is not same as the mass density of a medium. We also have heard about density in terms of mass and volume, but this idea of optically rarer medium and optically denser medium has nothing to do with the mass density. It is very much different. Both the concepts are very much different. Just keep that in mind. So this is all about the refractive index, which is a very important topic, and certain conclusions that we obtain about the media with the help of refractive index. Thank you.